To start with, I would like to welcome Yongxing Wang to the stage from Acros, and they're going to be discussing the challenging AI application in end-of-line inspection of a very hot topic, prismatic batteries. So obviously, battery market is a very much a growing area. So looking forward to listening to all the information. Welcome.
I can use this, right? OK. OK, good afternoon, everyone. My name is Herzen Wang, from Acros. Actually, Acros is a company from China, the headquarters in Beijing. But we just newly registered our office in Berlin. So right now we are GmbH right now. So I'm really looking forward to do some business here in Europe. And the topic today for me is around the challenging AI application in the battery inspection. The EV battery right now is a very hot topic. So how to use AI to solve some challenging topics, pain points in this industry is what I'm going to talk about today. Since Acros, we are newly registered here in Europe. So first of all, I would like to introduce a little bit more about the company. For us, Acros, we were established in 2017. So this is kind of the 7th year for us. After the establishment, basically we're focusing on solving some very challenging inspection tasks within the industry-wide. And for us, we are able to provide some standard AI software. At the same time, for some special key account, we are able to provide the turnkey software solution or the vision solution for our customers to do some customization. And the industry-wise, the consumer electronic, it contributes around 40% of our revenue. The EV battery, it contributes around 20% of our revenue. And the EV battery is what I'm going to talk about later. Just a summary. Right now we have around 450 employees globally, and more than 14,000 of our AI licenses have been sold across 800-ish factories, directly, indirectly. They are stably performed within the factories. So right now it's a time to go to the EV battery. During the EV battery cell manufacture, there are 3 main manufacture stages. The first one is about the electrode manufacturing. After the coating, the calibering, and the slitting, basically the visual inspection with AI is essential to it. There are a lot of factories, machines doing this. And the second one is about the cell assembly industry. For this, there are the notching, stacking, tap welding, can insertion, and also the other 2 processes. Basically, after notching, stacking, the welding, insertion, visual inspection with AI is required. And the last one, about the formation. And today I'm going to talk about the last one of end-of-line inspection. And this is one of the most important stations and one of the most challenging stations with AI. For the EV battery, just in general, the pain points. The first one, of course, there are so many defects on the EV battery. And if you miss any kind of defect, it might cause fire or explosion. So usually the acceptance is very strict. They have to achieve 0% escape for many critical defects. The second one is about the inspection speed. For example, with the coating and calendering, the basic speed is around 6 meters per minute. And the medium speed is around 120 meters per minute. And the maximum right now we have tested is around 180 meters per minute. These have a very high requirements on the software or the algorithm performance. And also, for the cylindrical cell battery, the end-of-line inspection, it has to reach around 300 pieces per minute. And this is also a very high speed. The third one, of course, it's not limited to the EV battery. I think it's something in general, the shortage of the data. And you have to solve it to shorten the data collection period. And the last one is about the scale-up cost. Like right now, I think many companies, they have done a lot of POC, but it's very difficult to make money with AI. Because like for one model, you have to cover all these kind of shapes, models, colors, sizes, and sometimes like the AI model, they just not so, the generalization is not so good, and the cost is very high. So yeah, we are going to talk a little bit more about for this end-of-line inspection, how that for challenges look like. The pictures on the left side is kind of like what a standard prismatic battery with blue film looks like. Usually for the inspection of this kind of end-of-line, it has to inspect all the 6 surfaces, like top, this is like the top, bottom, front, back, left side, right side, these 6 surfaces. And also on the lead, like the terminals, the injection hole, the vent, the QR code also has been inspected. Especially, those kind of edges, corners is also something we have to inspect, just in case, just make sure that no like defects of bad quality will run to the next station. And the inspection speed for this is around like 24 pieces per minute. And critical defects, those defects we have around like 5 defects. For this, is if you miss the inspection of this kind of defect, it's like the function-related or the security-related defects. And there are around like more than 50 types of defects for the normal defects, like some small scratches, bubble particle, etc. For this kind of normal defects, usually like they are able to accept a certain percentage of the escape. So the general target, like 0% for the critical defects, and for the normal defects, they can accept around 0.2% to 0.3%. And for the overkill rate, like from factories to factories, from models to models, they can accept around like 2 to 5% of the overkill rate. And apart all of this, for any kind of like machine builder or system integrator, they have to make sure that one system, they are able to cover several different models. So for this, the system have to be able to cover the different size of this kind of prismatic battery and the film color. All the projects we have like tested, they have the black film, they have like the blue film, which is the most popular one. We also have the green film, like golden film, silver film. The black one is very difficult. Right now, like we still don't have a very good solution for the black film. But for the blue film, green film, golden, silver, it's something like under control. And also the layout of this kind of the lead, the sequence is different. Something of it might be missing in different companies. And the film coverage, for some models, the blue film, they cover all of the surface. But some of them, they will maybe, like the bottom side, it only cover part of the surface. So also we need to cover it. And the shape of the vent, it can be oval, it can be this kind of like rectangular, and terminal shape as well. They have like different shapes. The vision system, also the software, they have to be able to cover different kind of situations to make sure that the scale up cost is like under control. Yeah, so for the end-of-line inspection in general, despite more than 50 types of defects, and sometimes the image quality is not so stable, is not so consistent, and you have to achieve like 0% critical defect escape, 0.2 for the normal defects, and 3% overkill. And for the speed, the third generation of our vision system, there are like 12 cameras, including 2D cameras and 3D cameras. And we have to process around like more than 20 images within 2.5 seconds, including like, get the data, process, and give out the final results. This is like also a very big challenge. The third one is like, for the end-of-line inspection, the overall yield is more than like 95% usually on a factory. And for our AI model, it takes 3 to 50 images to build the initial model. And there are some defects, the long tail defects, such as one of the critical one, the vent contamination. Basically, per each line, we can collect around like 10 engine samples of this type. within 1 month. So it means if we want to collect like 30 to 50 NG samples for this, it will take around like 3 to 5 months. That's unacceptable for many factories. This is very time consuming. The last one is about the scale up cost. Until right now, we have done like 3 generations of the POC test. And basically, each generation of the POC test, it takes around like 5 engineers for 6 months to finish like all the process and achieve the final target. This is like very expensive to do this, and this is very like highly know-how based. So our software, our algorithm or solution, we have to be able to totally solve or partly solve these kind of like 4 problems to make this solution accessible by the customer. The first one is about of course, is about the AI network. Then we have done like some special optimization on 3 aspects. The first one is like the cross-layer connections, and also the second and the third is about some like unsampling, upsampling, and the resampling technology to make sure like the neural network they are able to detect the defects with higher resolution and with faster inference speed to make sure achieve those kind of very strict standards and to process all the data within 2.5 seconds to make it possible. I'll give some examples. The first one is about one of the critical defects. For example, with the blue film damage, usually like the general standard for this defect is like the size larger than 0.3 square millimeter. They have to be detected as a defect. And usually the 3rd generation of the vision system, the pixel resolution is around 0.04 millimeter per pixel. And we need to do some mathematics here, and it contributes around like 187 pixels. So for our algorithm, since the accuracy is a little bit higher, so the real edge we output is closer to the actual value, actual size of the defects. So it means when we set the final standard, like the size larger than 0.3 square meter, it's a real defect. This value is more trustworthy output by our software. The second one is about the GPU. What kind of GPU do you have? Or do you need to use? For the 3rd generation of the system, like 12 2D line scan images and 5 2D area scan images and 3 3D images are taken for the whole system. And within this, we use like 2 RTX 3090 to process all the data within like 2.5 seconds, and with the help of our customized like defect net neural network. Then the last one is even for the same defect, for example, like foreign matter, when we do the project, there's a difference between the soft foreign matter and the hard foreign matter, and they have different standards. And even for the same defect, for example, the soft foreign matter, the real standard on the front and back, left side and right side, and the bottom, and the height tolerance is different. So this is very know-how based, and our network, they are able to support this kind of multi-tag classification and to set those kind of very complex rules within the software, set different kind of filters. This is about the network. The second thing is about the data shortage thing. We have our AI defect generation tools, and on the part is some real NG data, and the second is about some generated data with our software. So basically, we are able to enlarge the training set around 30% to make sure the performance of the model is more robust. The second one is the data collection period. Right now, for example, you have collected 20 real NG data, and you can use the software to generate another 10 NG data. So altogether, the other 10 NG data, you can save this kind of time, more than 50% of the time saving during collection period. The last one is we have made the comparison. For one project, we only use 20 real NG data. The other one, we use 20 real NG data and 15 generated data. and we compare the performance of these two models, and it can achieve around like 35% more accurate for the initial model to make it like to deploy in the real application case. And the last one is about some scale-up tools. Of course, you know, the AIDG, as I mentioned, and the image tuner to make sure like the different copy lines, they have very similar like image effects. So one model developed for one line, they are able to cover the rest of the other copy lines. And the private server within the factory, they are able to realize some data central management. And also, if there's one new model update, then with one click, you are able to deploy all the new models across lines. And with the AIDG and others, we also have collect some like defect library. For example, in this end-of-line inspection, we have collect this kind of like defect library, like on the terminal, this kind of like stains or dirt. We are able to use the defect library to generate the model. You don't have to collect more NG samples anymore for this. These kind of data are generated with our AI software. So as a result, from like data collection, training, optimization, right now it takes around like 1 to 2 engineers for 1 month to finish all the scale up period for one machine. This is a huge save. That was kind of like the general information. Then the last page is to introduce a little bit more fun application cases to combine AI with other technology, including with a programmable light for the crack inspection, and to combine with 2.5D, 3D imaging system, some welding inspection, and also some very high speed and image taken and stitching system, and also to combine with the X-ray. That's also some other interesting cases in the EV battery. Yeah, this is about my presentation, and our booth is at Hall 8, B50, right over there. Like you can just drop me an email or stop by at our booth to get to know a little bit more information. Please scan me. Yeah.
Yongsheng, thank you very much.
Yeah.
That was very interesting. Before I ask a couple of questions, are there any questions on the floor that people would like to ask? So obviously battery inspection's a hot topic in this new era. Is that where most of your AI is used, in the battery inspection, or is it a small percentage?
Because like we have like the consumer electronics, like it contributes around like 40% of our revenue. Right. And the EV battery, like it contributes around 20% of revenue, but it's increasing a lot. And we noticed a huge trend because in the past we were doing the business in mainland China, and right now a lot of like local European companies and some Tesla American companies, and they are building factories like in Europe, in the USA. So they, because they start a little bit late, so like right now they are looking for this kind of solution to help them to improve the manufacture like process, the yield rate, to help them.
Okay, and I saw that you obviously use a lot of different technologies, 3D, yes. 2D, 1D. Do you design the setup of the camera technology, or is that your customers' expertise?
For us, you know, we have the special advantage as software and algorithm. So for this, some of them we will cooperate with some like machine builder or system integrator to customize some light or to design the system together. Okay. Because you know it's a combination between the hardware mechanical system with the software. We need to adjust our in accordance with each other.
So a lot of your business, half of it is the core AI,
yes.
and the other half is the optimizing, customization, yes. for the application.
Yes,
okay.
Exactly.
Thank you very much. Well, I think that's a great example of what's needed for this growing market. Thank you.
Yeah,
Brilliant.
Thank you. Thank you.
So next up, we've got, obviously AI is a hot topic and also embedded is a hot topic. So we have Jens Will from NET New Electronic Technology to look at the efficient integration of AI in embedded vision applications. Welcome.
Title.
Sorry?
It's a long title, yeah.
It's a long title, yeah.
So, hello ladies and gentlemen. Welcome to my short impression about AI use in artificial intelligence applications. My name is Jens Will from NET Company, and we are a Take Age Vision Group company. And I hope you enjoy the show. And let me start with my introduction. As I already told, my name is Jens Will. I'm the Business Development Manager. And if you have any questions anytime, don't hesitate to ask. What we do exactly is we create embedded solutions, hashtag cloud computing, hashtag edge computing. So cameras do the whole job. We have centralized vision technology. In our camera, the whole magic happens of finding the mistakes, finding the obstacles, defining the field, and delivering back just the answer, good, no good, and the image maybe. We are based in the medical business, very famous for industrial solutions, and also we deliver the correct optics, whatever customer needs. We have the unique solution, so it means you have the problem, we find the right solution for you. What we see here is our three basic cameras. The Gigi Pro is a high vision solution with an IP core and a FGPA processor. But we have the decentralized smart vision solution, the core side is Windows-based, and we have the IM camera, that is our latest development. It's Linux-based. It's more or less the most modern way to inspect your solutions with an edge computing device. Let me take you on the journey with a small video. Oh yeah. So let's have a deep dive inside our camera. Here you see what we do with your problem. We create your embedded vision solution. So this is the IM camera. The optics, we are very creative. We have a standard C mount, but also be flexible with an F mount. Whatever is needed for your application, a small S mount, depending on the area of interest and on the work field that we concentrate on. Also, variety is the spice of life. So heat dissipation happens as our processor is creating a lot of heat. We have passively cooled. In this case, it's very important for the medical industry to avoid decontamination by the process. The whole camera is equipped with an ARM processor that does all the calculation work inside, AI-based calculation on the rules that you define for your product and your problem. We have a big variety of sensors. We start with the normal matrix sensor and optical lenses, but we have also line scan sensors, and latest in the field we go to shortwave infrared sensors, near field infrared sensors. We can carry the whole spectrum, whatever filter you define. Even multi-sensor optics for 3D vision applications is possible with our camera. So what you see, variety also is compared to the field bus. Every common field bus is supported. Profinet, Profibus, every field bus can be equipped with our camera, whatever is in your need. We have a different housing if you have waterproof options. So the core side housing is waterproof, IP67. For agricultural solutions, it's very common use of this application. So it's just a small variety of what we do for you. Factory automation is where we come from, but also logistics is more and more common for us. Food sorting is where we just started, and machine control of baseware, of agricultural solutions, sea rotten products, liquid packaging, very interesting for us as farmer inspection also. We work with big players on the farmer inspection market to scan products before they deliver to the customer for defects, for spillage, for breakage in the glass. Everything's possible with our camera. So let's go further in the near field infrared and the shortwave infrared polarization. First of all, with visible colors, what we do is segmentation. So you define what is cat, what is lawn, what is sky, and the camera by itself, deep learning process, can easily define this on pictures and create a network for this, and afterwards the classification runs by itself. Also quality control classification, what we do here is check an apple for inside heating or inside water to find out if the apple is rotting already. It's very important to find the rotten apple, to take it out of the big batch to stop other apples from starting to rot. It's an agricultural solution. Anomaly detection with polarization sensors plus sphere sensors. We can have a deep look inside cardboard or plastic wrapping around. The plastic wrapping will disappear at a different scale of nanometers. We can have a deep look inside and see if there's camera, oil inside, if there's water inside, or is it the right filling of gummy bears inside from the outside without opening the box or the crate or the package. So this is just to show you the difference between a smart cam and a standard cam. We also have standard cams, but we are more specialized on smart cams. First of all, you have the sensor, it takes a picture. The trigger management and the encoder management, that's common to our camera. And then you have an interface to transfer the image to the computer, to some PCI next to your next to your application, where the whole calculation is done. The difference is in a smart cam, it's all integrated. You have the sensor in front that takes a picture for you, and then you transfer the data inside without a cable or something. You directly do all the calculations inside the smart camera, and what's exiting your camera is the decision, is it a good or not good product. Plus, you can also transfer the picture. If it's a no good product, you can transfer the picture to your cloud, and then later decide whatever the computer was wrong or the logic was wrong. If it's a good product, you can afterwards qualify the picture. Just to show you, give you an overview about what's inside happening. So as I told you, it's an open camera concept. That means the training, the optimization, and the runtime is all your decision. Our customers decide which software to use. We don't give you any software on your hand. It's your decision, open camera concept. You can go with TensorFlow, Keras, PyTorch, Caffe for the training. Afterwards, optimization done outside. And afterwards, the runtime with the Hulk and OpenCV is done inside our camera. We can help you find the right software for you. We will support you, but you're totally free to use the software you like for your application. Again, AI-based segmentation in agricultural is done by an image database that has to be very complex. The whole training is done by pictures you take. It's all about annotation of the pictures, and afterwards you do the training on the vision system and upload it on the neural network, and the whole device is then integrated into your farming device, your tractor or whatever you use to harvest, to crop, to inspect your agricultural products. We have this for a customer in the wine planting. You see, every autumn the wine grapes have to be cut back, and there's pillars inside. So if you cut back the pillar, you need a new scissor afterwards, and that's why we use AI to identify the pillar from the grapes and open the scissors for the moment when there's a pillar. It's a very late design that we actually install in German wineries and all over the world in the near future with this product. Stereo smart cameras with industrial solutions for inspection of steel rails, of wood, of gaze for healthcare products is done with stereo inspection. We have a running system. Video won't start. Oh, here it comes. Yeah, that's for big rails for camera for rails to discover anomalies in the height or defects in the surface. Also done with such inspection system on a stereo base with two cameras by one edge device. You see, it's an on-semi-rolling shutter. In this case, to maintain the high speed of the rail running through, and all calculated by the IP core, giving back the right decision. What we have here is it's more or less a demonstration we had on the trade fair last year. It's a teachable edge device. So 2 cameras in a small distance, check, have a close look on the product and see if it's good or wrong part, and by air pressure can kick out the wrong products for sorting reasons. Let me show you this in the video. You see here the products are filled in the turntable. By shaking they get transferred to the camera point, and afterwards, after the decision, we blow out the wrong parts and let the good parts pass. Here in a high slow-mo, you see where the parts are coming and where the decision is made, and by air pressure gets extinguished from this from the batch. Well, that's all for now. If you have any more questions, you can ask now or join us in our booth at Hall 10 F30. That's a TKH Vision booth, and I'd be happy to install this camera for you at the next application on your site. Thank you for your audience.
Jens, thank you very, very much. Firstly, any questions the floor would like to ask? So obviously you showed a lot of examples there of applications, and you were showing what the hardware is. How flexible is that? Is everyone custom, or is it a standard set of sensors and processors?
We have a wide variety of sensors, but still get more and more with every application we do outside in the field. Yeah. There's so many ideas and so many applications. Our core business is to be very open to these and find the right solution by defining new sensors. Especially in the sphere near case, it's just started. The magic just started. Okay. And for the AI side, is there a choice of back-end processor, or is it one processor for that, or? In this case, we're using 2 processors. One is by ARM, and the other one is by a customer from our side, from inside internal customer. But over here, we don't use NVIDIA by now, but in the near future, whatever is needed, maybe we have to go to NVIDIA way too. But then we can use the unit as a toaster, maybe. Okay, brilliant. Well, Jens, thank you very, very much. Good speech. Thank you. Right, thank you. Now we're on to the third talk on the AI area, and this is from Near Advanced Machine Vision. Jose here is going to talk about the low-code approach to Industry 4.0.
Thank you so much.
Interested to learn all about this. Thank you.
Thank you. So, hello everybody. My name is José Pedro Ferreira, and I'm the product manager from Near Advanced. And today I'm going to talk to you about our new platform, NIOP. This is our low-code approach to the industry. So, first, let me speak to you a little about Near Advanced. Near Advanced is a machine vision company which develops machine vision solutions for the industry. We are founded back in 2001, so we have a long history of developing solutions like this, and we have a high qualified team that we build with many years of experience develop this type of systems. We have installed systems in more than 18 countries and in 4 different continents, and we are in fact we are located in Portugal, and we were the first Portuguese company to support systems like this, and the first one was to the German market. So basically we deliver OT solutions for the shop floor for the industry, and we applied our solutions to every kind of processes: quality control, inspection, automation. We have systems doing guidance for the robots, monitor, detect different fixtures, and so on. And we also have a lot of experience in exchanging data to the IT systems. So to collect the data and to send everything to the MES and to the KMS systems, and on the other way around, to grab that information and apply that information to the production floor and to the shop floor. Our key customers are mainly on the automotive market. We have also on the aeronautics, but mainly this was the type of companies that asks most for this kind of devices that we have, and we use the same software to inspect electronic equipments, door panels, car seats, tires. It doesn't matter. We have our solutions have the ability to extract information from the images, and it doesn't matter what type of images that we are inspecting. So a couple of years ago, and after 20 years of building this type of solutions to the industry and develop this type of solutions, with all of this expertise that we have, we decided to develop NIOP, which is the low-code platform to allow other people to build solutions by their own. So the idea is that everyone will be able to program and configure their machines using and interact with other industrial systems within this low-code approach, and based with this drag and drop concept to build your solutions. So I have just a small video.
The world in permanent change, an industry increasing its complexity at an extraordinary fast pace. This is where NIOP comes to life. NIOP is the low-code platform that brings simplicity, completeness, and speed to orchestrate the operational technology layer of multiple industries. It allows anyone to program their own machines, anywhere, at any time. And when we say anyone, we really mean anyone. But how, you may ask? Based on a drag-and-drop concept, NIOP gives companies the right tools and an easy-to-use interface to control intelligent systems, maintaining the quality and the control required for their applications. Built to simplify everything, with NIOP, you don't need computers' programming knowledge. It reduces time to line up to 60%. It reduces up to 68% of project cost. NIOP helps you program machines that implement pattern recognition, pick-and-place systems, and visual quality control systems, just to name a few. All done in the blink of an eye, and with highest quality already built in. Okay, you can stop imagining. This is real. With NIOP, it's that easy. Know more about all features at niadvance.com.
So this small video is only to illustrate the idea of behind NIOP. So as I explained, this is a low-code approach. So the idea is that you are capable to deliver the solutions a lot faster. So any citizen developer is able to do it. You don't need programming skills to develop your solutions, and at the end you maintain the quality and the performance of the solution built in on your systems. So we can use NIOP to orchestrate all the OT stack. So we have a lot of communication protocols, a lot of tools to communicate with different cameras, different sensors, to communicate with different tools, PLCs, robots, and we have a lot of tools also to send information to the cloud, receive information to the cloud, give data and information to the digital twin systems, and with user interface that's simple to use and to manipulate. Just to speak to you a little about the architecture of NIOP, we can divide it into these three main components. We have the cloud, so where is a client's area mainly, where you can store your tools, you can buy components, and you can monitor all your machines. We have on the laptop, we have what we call the NIOP Studio. That's the tool that you use to design and build your program. And after designing the program, you can publish the solution to the machine. So you can publish, currently NIOP is able to use Windows and also Linux, so you can publish to either one of these operation systems, and the solution is ready to go. So the components, here is the overview of the studio, where you design your program. It's very intuitive, with a very simple interface, and after a few minutes you are able to create the solutions very fast. The engine is where the solution will run, so this is responsible for executing what you build on the studio, and as I told you, we can have the engine running in Linux and also in Windows. And then we have the HMI editor, so you can fully customize the end user interface and your HMI for the machine. So you can have multiple HMIs if you want to build one specific for the machine and one specific for the office. You are able to do that in a simple way, so it's very intuitive. You have a lot of controls available, and you can adjust basically your needs. After completing the solution with the HMI editor, of course, you have the HMI concluded, where the final project the user can visualize the real-time execution of the program is just built in. Going a little deeper into the concept, we have the tools that are the basic elements of the platform. They are divided into multiple categories. We have tools to perform image acquisition. We have tools to manipulate 2D image, 3D image, tools to manipulate point clouds. We have also a lot of standard communication protocols to communicate with the different robots and PLCs. And of course, all the other tools to manipulate variables, to manipulate the files, and to communicate with the HMI. By combining these tools, you can build the workflow. The workflows can be simple, with just one path, or can be really complex with multiple paths and multiple branches. And we also have the concept of the sub-workflow. That is, if you want to hide the complexity of a big workflow, you can structurize them into smaller sub-workflows to make the solution faster and readable, and improve the performance. We have also the ability to do parallel processing. So if you want to speed up your processing times and improve your performance, you can also do that with the tools available on NIOP. We have at the end the HMI and the reporting. So as I told you, you can fully customize all the HMI for the end user. You can visualize your data, you can have graphics, you can have tables, you can track the production trends and the times, and oversee the KPIs. So we have already pre-built templates, or you can start from scratch and build your HMI from the beginning. We have also AI capabilities inside the platform. It's basically an interface that allows you to create, train, test, and deploy your AI models. This was not made for the data scientists. The idea is for everyone on the production floor that wants to retrain, see the behavior of a model. He can easily do that. So again, it's a very intuitive user interface. Right now you have the possibility to do classification, detection, segmentation models, and you can do from the scratch, start a model from scratch to do the notation, the train, and to define all the parameters, or you can use a pre-trained model and adapt from there, test the model and deploy then to the final machine. Here I just have a small video with a demo of a constructor of a very simple workflow. It's just a simple QR code read, just for you to see how is to manage in NIOP. Well, the video. is not starting. So let me... okay. So here it is. We are, as I told you, have the studio. That is where you build the program. You can start a project from scratch. You put a name on the project. You can have a description if you want. And here is the environment for developing your solutions. You have the tools on the right side, and you can drag and drop each one of the tools that you want to define. You can define all the parameters. You have input parameters and output parameters for each one of the tools. So you can create variables along while you are building your workflow and continue the process. Here we just are reading a file from a folder. Then we are reading this tool to read the barcode, and we are storing the barcode on the result string, and that's it. You just need to do these simple steps. On the bottom you have the debug, where you can check if you are doing everything wrong, right, and you don't have any problems. And at the end, you just need to publish the solution, and the workflow is ready, and you have the result. So, in a very simple way, you can build from scratch simple projects or really high complex projects with NIOP. So, as you saw, we have this. This is the main overview, the workflows, the HMI pages, all the tools divided into multiple categories, and on the bottom the debug, where you can see if everything is running okay and if you don't need to adjust anything to the workflow. So just a few more examples. If you want to communicate with cameras, we have the GeniCan standard implemented. Besides GeniCan, we have also other types of different cameras already pre-built in NIOP. So another example of the parallel processing capabilities. If you want to do parallel tasks, you just need to pick the parallel tool and add all the sub-workflows that you want to the system. Also, the one example from the communication with robots. If you want to communicate using any protocol, you just need to write and read registers like this in a very easy manner and with an easy approach. We have also the possibility inside NIOP. If you want to use external DLLs that you already have built in other contests, you can also include use that external DLLs inside NIOP, or if you want to create shell processes, you can also create a shell process inside NIOP to communicate with the other protocols. The HMI editor is very similar to what you saw on the studio, so you can create your pages, divide them into different blocks. You have all the basic controls, and again, you just simply need to drag and drop them and build fully customizable all your HMI. You have the test. You can change all the settings that you want to build it. So, on the last slide, I just compiled all the advantages to use NIOP. So it's simple. There is no technical knowledge needed to use the software. It's very complete. We have a lot of different tools, 2D, 3D tools, and robotics and automation tools. It's fully agnostic, so we can use any brand that you want to use inside NIOP. It's really fast. Since you don't have to do any software development, it allows you to develop the solution faster. And at the end, if you build it faster, you can reduce the overall cost of the project because we'll do it faster and with less qualified people. So if you want to know more, please visit us here in Hall 10 on stand B35, and we'll be welcome to show you a little more about NIOP and schedule a demo with you. Okay, thank you.
Thank you very much. Very interesting. Making things easy is an important key in this expensive world. Any questions from the floor? No, great. Well, looking forward to coming along and have a look at it. So, obviously, you mentioned GennyCam as the standards. What other standards to connect to the PLCs and stuff? Do you have standards there?
Yeah, we have the standards we have implemented.
Yeah.
Yes, we have SysOPCUI, Modbus, Profinet, Profibus, Ethernet IP, MQTT. So we have a lot of different communication protocols that allows you to, in a simple way, communicate with
and the runtime, what platform, PC or ARM, or what's the platform that the engine can run on?
The engine can run currently in Windows and also in Linux. We have a partnership with NVIDIA, so it runs also in all NVIDIA boards right now. Not the studio part. The studio it's on Windows, but you can deploy the engine for other operation system.
Fantastic. Well, thank you very much, Jose. That's really interesting.
Much.
But that concludes the AI session. We'll be back here in 10 minutes for the next phase. Thank you.
Thank you.